Today I will talk about the steps of setting up the R40 device. There are two ways to connect your computer to the R40. One is to use a network cable to connect directly to the LAN port of the R40. The IP address of the LAN port of the R40 is 192.168.3.1. It can assign an IP address to the computer. Access it by entering 192.168.3.1 in the computer browser. Another way is to connect the WAN port of VR40 and the computer to the upper level router at the same time. Enter the IP address obtained by the WAN port of the R40 device in the computer browser. For example, this one. After entering, enter the device's username admin. The password is empty. Click to log in. This screen shows the status of the R40 device. It generally doesn't need to be modified. This includes firewall status, root list, system log, and kernel log. This shows the working status of the device. Next is the system settings. The system settings can set the device's time, hostname, time zone, status, and NTP calibration server, change the language, etc. Click Administration. You can modify the device's password and set up SSH authentication login here. Some small programs can be installed into R40. This is for developers to use. These are also some functions provided to developers. Generally depends on the needs of the customer. This is the backup, upgrade, and recovery of the device. And save some status of the device. Mainly used for generating archives and uploading archives. Below is the option to upgrade the firmware of the device. Here you can choose an upgrade package we provide. Next, look at the network port settings. We can see the parameters of the LAN port, WAN port, and 4G interface. You can set the switch between the WAN port and LAN port of the device. Switch the WAN port of the device to the LAN port to make it act as a switch. This is the global network option of the device. The second is the Wi-Fi option. The device can provide Wi-Fi to the following devices, and can also connect to the Wi-Fi of other devices. For example, connect to the Wi-Fi of other devices. Click Scan. You can connect to non-Wi-Fi. Or add the Wi-Fi provided by the device to realize the Wi-Fi function. The third one is the cellular network option. If the R40 device has a 4G card inserted, you can get the status of the SIM card and the APN settings and GPS options in this screen. The device's GPS information will only be uploaded to the cloud platform when the device uses the MQTT protocol. The following is the automatic switching function of the SIM card. If the SIM card automatic switching function is cancelled, the device will only use SIM card 1 or SIM card 2, and will not automatically switch networks. If the device is connected to the internet through SIM card 1, and the network is abnormal, it will not automatically switch to SIM card 2. These are some of the network functions of the cellular network. Set it up as required. This is the domain name binding function. The following is the host mapping function. This is the static routing function. This is the network diagnosis. After configuration, you can ping some IPs, test whether it can be pinged. Then there is the firewall. You can set up port forwards as needed. Finally, there is the network sharing function. R40 device currently supports 3 kinds of VPN. You can refer to the specific setting methods of each VPN, which are all added in the same way. Add a name. Click Add. Then click Edit. You can modify the parameters of the VPN. After modification, click Save. Back to Overview. Click Save again. The VPN function can be added. The other two are the same. This is the remote I/O function of the R40 device, which includes a serial port and data acquisition functions. This is the status setting of RS485 and RS232. This is pass-through. The pass-through function means that the RS232 port or RS485 port of the device can be used as a TCP server. Pass-through means that another host computer can access the R40 device. An IP address and a port can be used for pass-through. The next step is to set up the device's DI and DO. DI has technical functions and enable options, while DO is responsible for the input and output of the device. Below you can also set the alarm function of the R40 device's native interface. For example, you can set the status corresponding to each of DI1 and DI2, or automatically trigger the alarm function when the counting function reaches a certain preset value. Next is the setting of IN, which is a function of the device, and some models are equipped with this function. IN supports 3 input modes that need selection according to the deep switches of the device's IN channel when using it. And these 3 modes mainly include 0.5 volts for 20 mA and 0.20 mA. After completing the above settings, you also need to set the range of the sensor and click the Save button to save all the settings. It can automatically read the parameter value of analog input. The following alarms are the same as DI and DO. Modbus RTU to TCP is mainly used to connect sensors, with RS485 or RS232 to serial port interfaces to the master or host computer in the LAN. Through this function, the host computer or host can directly use the device's IP address and port to send Modbus TCP commands. Then the R40 device will convert the received Modbus TCP commands into Modbus RTU format and communicate directly with the serial port device. This process is somewhat similar to pass-through, but the difference lies in its specific use for conversion between Modbus RTU and TCP. It is divided into RTU Modbus slave and TCP Modbus slave. If you choose to use it as an RTU Modbus slave, the corresponding serial port cannot be occupied by other functions, such as pass-through or Modbus RTU master function. Otherwise, this function cannot be selected. If you choose to use it as a TCP Modbus slave, you only need to check and set the corresponding network port. And check RTU Modbus slave, because we will use Modbus RTU master later. Let's talk about Modbus master. The R40 device can serve as a Modbus master to collect sensor data or I/O device information from some slave stations. First, add a name. Enter the slave adding interface. Set an alias. For example, water level sensor. The Modbus ID of R40 device can be filled in according to the sensor ID. The following is the data type, including bool data, 16-bit and 32-bit data options. The bool data corresponds to input quantity input and input quantity output, corresponding to 01 and 02 function calls respectively. Take adding 16 bits as an example. Input sensor function code. Select the corresponding data type. There are 16-bit signed and 16-bit unsigned. This is the registered starting address value of the sensor. This is the number of sensors. The following mapping registers are generally kept by default, and this polling period is generally 0.2 seconds or 200 milliseconds. This is the response timeout. The default timeout is 0.5 seconds. Select RS485 or TCP slave for the slave interface. Enter the IP address and port of the slave. After configuring these settings, click Save, and then continue to click Save. This includes the sensor name, alias, sensor Modbus ID, registration type, function code, registration start address, data number, mapping address and slave interface. If the slave is connected and online, click Modbus Query. Select the slave, data type, slave address, and configuration name. After selecting, click Display Channel to view the data. Since the sensor is not connected, it is impossible to read the data. This is mainly used for acquisition function. Next is to set up the email and SMS alarm functions. After enabling the email, enter the email's SMTP server address and port. This is the recipient email address. This is the sender's email address. Next is the username and password. This password is not the sender's email password. It is an authorization code. After the SMTP function is turned on, there is an email authorization code. The authorization code and email login password should be distinguished. Below is the email alarm function. For example, after we set up DI or AI trigger, it can send an alarm email to a specified email address. The SMS settings are similar. You can add the phone numbers to receive the SMS, and remember to include the country or region code before the number. You can also choose the language for the SMS, which supports both Chinese and English. This is the network disconnection alarm setting. We can add an R40 device to monitor the network. For example, some LAN IP addresses can select the number of ping times. It can also trigger actions like linking to the O or the input/output of the R40 device. Set it to close or disconnect. Turn on enable alarms, and save the settings. After selecting the alarms, we can set other alarms. For example, when the device is offline, you can set the SMS content after ticking the box. For example, PC1 is off means the first computer is offline. You can also set the content of email alarm. Remember to save it after setting. If no content is provided, the default alarm message will be sent to the corresponding email or phone number. This is the timer setting. Timer settings are a bit more complex. For example, this is the timer alias. And here is the time interval with its unit. Below is the action, choose the O1 or send email. For the O state, choose either close or open. Edit the email content and choose to send the local I/O status or Modbus slave data. You can set a scheduled send, such as every day or a specific time, or none. You can select a specific time each day to send the device status to a designated email, or have the device perform certain actions. This is the weekly timer setting. This allows the device to perform an action daily or weekly, with settings similar to the timer. This is a one-time timer. It will not be executed again after it is executed once. The setting method is similar to the previous timer. First, set the alias, then set the month, which is calculated based on the current time. For example, set an action to be performed at 0:00 on December E Street. The device will perform the corresponding operation according to the set time. This is the arithmetic operation function of the device. It allows to combine different data points and select mathematical operations, such as addition, subtraction, multiplication, and division. You can also set operations like multiplying or subtracting specific values. The result can be output to a designated mapping register, and once set, simply check the box to publish. This is the function of the device's Boolean logic operation. For example, when the I1 is closed, you can select the logical and or logical OR operation to link another state, and pass the result to other sensors or register addresses to trigger the corresponding action. This is the logic operation function, which is a three-level operation. After obtaining an output register address through arithmetic operations, this address can be used for further output. For example, add one outputs the result to the REC4000 address, and then other operations can be triggered. Similar to the previous logic operations, this is part of the logic operation. Next, for the cloud platform settings, the process is the same as before. First, click Add, then click Edit. Here, you can choose to connect to 2.0, 3.0, or other cloud platforms. If you choose 2.0, you can use either the Modbus protocol or MQTT protocol. Let's first talk about the Modbus protocol. It requires setting the Modbus ID for the R40 device, which is a registration packet used for the device to connect to the server, and the server uses this packet to identify the device. Below are the parameters for heartbeat, heartbeat response, heartbeat period, and silence time. The heartbeat is mainly used to maintain the connection between the device and the server. Click Save. If you choose the MQTT protocol, it's the same. It has some built-in fixed parameters, and we only need to set the MQTT client ID and publish time. Note that if the MQTT client ID connects to our server, the customer needs to purchase it from the salesperson. You can also tick the data retransmission option, which has a compensation function. If connecting to 3.0, it's the same as the 2.0 Modbus RTU protocol, with the difference being the built-in domain, port, and heartbeat response. When connecting to other servers, more options can be configured, such as the server name, domain, port, and the choice of protocol, which should be confirmed with the server. Take MQTT as an example. Choose the MQTT protocol. First, the client ID, username and password of the device. Next is the encryption setting. You can choose a certificate file or a self-certificate. In general, no encryption is used. The data format can be selected as default or custom. If you choose custom, here is a sample template, which can be modified as needed, such as topic 1. You can use the $symbol followed by the device's I/O port or slave identifier and add it to the corresponding template. If you need to include a time window, you can append M and bring in the time. This is the setup for the custom template. Next, there are settings for the publish period and publish quality, which are the main configurations. If it is the default template, you need to set the device's publish topic and subscription topic. It is optional to upload the data to the server immediately after the change or periodically. Below are the relevant videos for Alibaba Cloud, Amazon Cloud, and Huawei Cloud. If needed, you can contact sales or technical support to get them. Let's talk about the ThingsBoard platform. This is the official platform. First, you need to apply for a username and password on the ThingsBoard website. Then enter the corresponding information to connect the R40 device to the official ThingsBoard server. If it's a private deployment, you will need to enter the IP address and port of your own server, while other settings remain the same as the official website. After the settings are completed, click Save. You can then log out. That's all for the device settings. If you have any questions, you can contact sales directly.